Now this is an easy problem from electrostat. Question says in a uniformly charged sphere of total charge q and radius r, the electric field E is plotted as a function of distance from the center. The graph which would correspond to the AVA will be. So we have to find electric field. So let us say we have a sphere, and this sphere is filled with, let us say, positive charge, and the charge is capital Q. So this sphere has a charge capital Q. So we have to find electric field first inside and then outside. Let us say what is the density, charge density rho is equals to Q divided by volume, that is 4 by 3 pi r Q. I am interested in electric field inside at a distance r from center. So we can apply E dot ds, Gauss law. E dot ds is equals to Q by epsilon naught. So if I apply this formula, now of course electric field will always be radially outward, and ds is also radially outward, so E dot ds will have simply E ds. So this is simply E ds because this is integral also, so this is the closed integral. So E ds is equals to Q by epsilon naught. Now electric field is in this direction and ds is 4 pi r square, radius is a small r. So E into 4 pi r square, this is equals to Q. So Q is rho into volume, volume is 4 by 3 pi r Q. So this is Q and this divided by epsilon naught. So from here we can find electric field. This is 4 pi goes, so 4 pi goes, and then we will have rho by 3 epsilon naught r. So this is for when r is less than capital R. When if you have r that is greater than capital R, let us say this is your sphere. Now if I am interested in a point that is outside the sphere, that this distance is r and this r is greater than capital R. So I am interested in r that is greater than capital R. In this case we can concentrate total charge on center and treat this sphere as a point charge. So in this case a sphere can be treated as point charge. Now in this case electric field will be, so we can place all the charge at center and Q by 4 pi epsilon naught, and distance is r, so electric field will be Q by 4 pi epsilon naught r square when r is greater than capital R. So we can draw the graph. So if we plot the graph, if r is less than r, it varies linearly, that is linearly proportional to r. So if so this is the case. So in this case let us say r is somewhere here, r is equals to capital R, and by axis we have electric field. So initially it varies linearly. So you see here electric field varies linearly, then it decreases with 1 by r square. So something like this. At infinite electric field will be 0. So if you see the plot, the same plot is in option number 2. So option 2 is the right answer in this case. Option 2 is the right answer in this case.